Welcome to September's Leetcode Challenge. Today's problem is carpooling. You are driving a vehicle that has capacity, empty seats initially available for passengers. The vehicle only drives east. It cannot turn around and drive west. Given a list of trips, where trips I represents number of passengers, start location, and end location, containing information about the ith trip, the number of passengers that must be picked up, and the locations to pick them up and drop them off. The locations are given as the number of kilometers due east from your vehicle's initial location. Now we want to return true if and only if it's possible to pick up and drop off all passengers for all given trips. Given that we have a capacity, can we pick up and drop off all these customers for the entirety of the trip? Say we're given this input here, we can see a couple things that we're going to pick up 3 passengers at 2 and then we'll drop them off at 7. But in the meantime, we will actually pick up 3 customers at 7. Or I'm sorry, we'll pick up 8 customers at 3, and then we'll drop those off at 9. So this creates a problem because these intervals are merging, right? This reminds me of the merge interval problem. How could we take into account how many passengers we're picking up and dropping off at all these times, given that these ranges are all they're overlapping? So can we sort this somehow to do that? Well, we could try sorting it by these start times, but that still doesn't solve the problem of these overlaps. Like if we had some overlap like this, we might be able to say, yes, we're going to pick up 3 customers at 2, then check, oh, we'll pick up 8 customers at 3. But like say this is 5 or something like that. Well, how do we know when to drop off these customers? Like we need to go back here. If this was like 10, we have to say, oh, okay, at 7, we're going to drop off 3 customers. So it's very hard to do this in sort of like a greedy method because we're not sure what information preceded us. So really, the best way you might want to do this, because we already know we want to figure out through this linear time, how many customers are we picking up and how many are we dropping off at every single time point. So we might want to just restructure this whole data set. And we could totally do that. We could just make this into separate this out into 2 tuples, and what we'll do is say separate this to a time, number of people, and whether this is a pickup or not. And then if we have this separate list to do that, then it becomes very easy to figure out have we ever exceeded capacity. So let's go ahead and do that. Let's say that we have a list, and we're going to like denormalize this essentially and say append this to this list in a different structure, right? So we have in trips the number of people, the start time, and the end time in trips. And we're going to append to our list a tuple of the time, which is start, the number of people, which is people, and whether this is a pickup or not. And for start, it's a pickup, right? And we need to do the same thing for the drop off, except this will be the end time, and this will be 0, because it's not a pickup. So now that we have this list, it becomes pretty easy. First, we want to sort it, and we'll say, all right, sort it by the first element, and actually sort it also by whether it's a pickup or not. And the reason for that is we want to drop off our customers before we pick them up, right? Because if this was tied, the time was tied, we don't want to exceed capacity knowing that we could have dropped off the customers first. So we'll just make that like this, and we'll make this a tuple. Okay, so now that we've sorted that, let's have our current amount of customers we have in our trip or inside of our cab or whatever, and we'll say for the time, the people, and whether it's a pickup or not in list. If it's a pickup, then we're going to add to our current, right? We'll say current, add number of people, and if it's a drop off, that's the only other choice, we will subtract the number of people. And if at any point we say if current has exceeded capacity, then return a false. Otherwise, we can get through the whole thing, then we could return a true. So let's make sure this works. Oh, capacity. Yeah, I love those typos. And there we go. So this is accepted. Now, time complexity wise, this becomes an n log n solution, right? Because of this sorting, it kind of makes it inefficient. It still works, but can we do better than that? It's pretty hard to do this in a linear way. One way we might be able to kind of do it though is rather than doing in terms of n, what about we take into account just the number of times, or have some sort of data structure that takes into account all the different points in time, since these are integers, all the way to up to the max starting or end point. And if we had that, we could actually do it linearly. So I'll show you what I mean. Rather than creating this whole sorting and denormalizing this list, let's create a data structure that's going to keep track of every point in time how much people there are. And to do that, we could just say, well, first let's find the max time. So we'll say, let's say for n time, because n time is what matters, for blank bank e in trips. We'll do a list comprehension and get the max time here. So this will be known as m. Now what we'll do is have this data structure with zeros right now with all the m's, and we're going to actually add 2 to take into account the time before and time after. And now this is going to, like, say for this example here, it's going to have a whole list of all the times up until 10. Like 0, I don't know if this is quite 10, but what we're going to do is like update this to how many people we're picking up at each time and how many people are dropping off at each time. And after that, what we're going to do is just accumulate this linearly. And this will give us like an indication of how many people are actually in our car at every single point in time. And if any of these exceed capacity, then we return a false. So that actually is linear, although we have to use m, not n, so it could be bigger. But let's see if we can do that, because it does make sense. For trips, we'll say for, again, people start end in trips. We'll get our lookup, and we'll say for the start time, and we'll add 1. We're going to add the number of people. And for lookup, end plus 1, we're actually going to subtract the number of people. So now we have this lookup, and what we'll do is accumulate it. We'll use the iter tools. And if we have the, if we do the accumulate sum for all, like this whole rolling sum for our array, then we just get the max, and we check to see does that exceed capacity, right? And actually we can just say if it's less or equal to capacity, the maximum, then we could do this trick, right? So we can say yes. If the maximum is less or equal to capacity, then yes, this would work. So let me make sure this works here. Looks like it's working. Let's go ahead and submit that. And that too works. Now, time-wise, it's kind of tricky. I can't completely tell which one's faster. It really depends on how long this trips thing is and how high this m is. But this is a linear solution, and this, approach works too. So either one, I would say either one is fine. All right, so thanks for watching my channel, and remember, do not trust me, I know nothing.